I'm Kaya, also Senior Software Engineer at CloudSign, and welcome to this session on intelligent monitoring of compressed images with Smart Image Hash. So this is a new feature, as Matthias mentioned, that we have introduced in our WebOrion monitoring system. So today I'll cover first about background. I think Matthias has shared briefly about our different monitoring engines and the problem of what Smart Image Hash is trying to solve. The problem is not new, and we have already had a lot of workarounds and existing solutions that we use with our existing customers. But this new solution, Smart Image Hash, will help to solve this problem more easily. Right, so for those who are new, WebOrion monitoring engines, we have 6 main engines: HTML content analysis engine, advanced integrity, image analytics, AI NLP engine, which Matthias just mentioned earlier. We have JavaScript malware detection engine, and we have the SSL/DNS and Whois monitoring engine. Right, so where the Smart Image Hash comes in is in the advanced integrity engine. So how the advanced integrity engine works is that on the web page, we have things like JavaScript, we have CSS, we have images, which those who are familiar with how a web page works, they should know this. So we will go and download all these files, and then we will go and hash them and check in. So with the hash, we can check that the image or the script is still the same. So for example, in this sample web page, you can see here, there's actually 6 images. We'll download each of the image, calculate the hash, and check that the hash remains unchanged the next time we check the page. So what's the problem with this is that while the hashing of the images allows us to check that the image is unchanged, the image file is unchanged, but images can look the same, but they still have different hash. So in this example here, you can see I have 3 different images, each one different size, right, different number of kilobytes, but the hash is completely different, even though they look almost exactly the same. And then here's another example. If let's say somehow the image is converted to another format, in this case it's a WebP format, the hash is again different. So for the user, when they look at their web page, they look at, hey, there's nothing different in the page, but why is it that the system is alerting me? Because we are looking at the hash, right? So just to recap what I said, integrity hashing notifies you if any thing in the image file has changed. So this one, the current method that we use, integrity hashing, any single byte that has changed, the image file is considered changed. So it will send an alert, and this is not what the users expect. When they look at the image, it's the same. So even more so when the compression is not done by the user. For example, earlier on, the images, they are smaller size, so they have been compressed. But if the compression is done automatically, then the user will be confused why this is happening. And this is not just a hypothetical thing, right? A lot of websites nowadays, they use tools to compress images automatically. And like I said, images look the same. Like another example here, these 2 images, different size, different binary data, but look identical to the user. So examples of this automatic compression, things like CDN, content delivery networks. Like in this case here, this screenshot, you can see Cloudflare has this feature. They call this polish, which you can ask it to automatically compress images for you. Some websites, they have web servers, the webmaster install this tool on the web server, like for example, Google PageSpeed, they automatically compress the images on the web page without the user's knowledge. Right? So the whole purpose of all this is with the smaller image size, the website can load faster. So if you never heard of content delivery network before, I'll just give a 1-minute intro here. A lot of websites nowadays, they use content delivery networks, and the whole purpose is that when you have a website, you run it on the web server is maybe only in one part of the world. But you may have users from all around the world, and what this content delivery network does is that they actually run many servers around the world for you, and then they cache the static content on your website. So things like your images, your scripts, they'll be cached on these servers around the world that are nearer to the users, so that they can get loaded more quickly. And many of these CDN, like I mentioned, Cloudflare is one example, they do automatic compression. So how it works is that your website visitor, when you visit in your browser, you actually go through the CDN and say, I want to load this image, right? My image.jpg. The CDN, if it have, it will just return it back. But if the CDN don't have the image yet, it will go and ask your web server, oh, do you have this my image.jpg? So your server will answer, oh, here's my image.jpg, and then the CDN server is like, okay, this is my image.jpg, but it can be compressed further. So it compress it, made it smaller, and then send it over to the website visitor. So in this case, this is what we mean by the automatic compression. The website visitor sees the smaller version of the image, and this means also our monitor also sees the smaller version of the image, right, the compressed version. But on the web server is still holding on to the original version of the image. Right? So in this case, the webmaster may be wondering, hey, I didn't change the image. Why is the system telling me that the image has changed? Right, so this problem is not new. I think I mentioned at the start of the presentation. When our customers have these issues, we tell them, maybe you can bypass your CDN. We monitor the origin web server directly. So in this case, we can avoid the CDN compression issues, and the image will be what the webmaster expects. Another way is we can ask the webmaster if it's possible to whitelist our monitor from the compression system, right? Whether is it a web server plugin or is it the CDN, and they can whitelist our IP address or the user agent that we use for the monitor service, right? So these workarounds still work and can be quite effective. Without the CDN cache, actually means that our monitor detects a change faster because you don't have to wait for the cache to expire in the CDN. But recently, we also have worked with a few customers and we realized that this not only requires a lot of additional configuration on the user side and on our side, it's sometimes not even possible. So we have this customer, what they do is that their website is not built internally. They actually use a third-party tool, one of those website building tools online to build their website. And this website building tool bundles in CDN with the automatic compression enabled, and the user cannot turn it off. So in this case, the workarounds don't really work. They cannot bypass, they cannot whitelist because the CDN and this automatic compression is not under their control. So with this smart image hash, we hope to solve these kind of problems. Right, and this brings me to what our brand new feature, which is the smart image hash. So what is smart image hash and how it works? So generally, smart image hash is just the name of our new feature that uses image hashing algorithms. Some people call it perceptual hashing, which is based on how humans perceive an image. So when humans see a small change, the image hash changes only a little. Compared to the earlier hash that I showed, right? A small change in the image leads to a big hash difference. So here's an example. You can see image hashing, right? Here is the same 3 images that I showed in the earlier slides. We have the same image, but 3 different compression levels, 441, 109, and 73 kilobytes. You can see that actually the hash shown is almost the same. There are a few differences, probably due to when you compress the image data a bit lost. But overall, from the human point of view, it looks the same, and the image hashing algorithms will reflect this, that the hash will remain very similar. If you want to compare the blue words here, this is the hash shown from earlier, the integrity hash. And you can see that integrity hash, even though the images look the same to the human, to our eyes, the hash is completely different. So that's how the smart image hash works, right? Instead of comparing the integrity hash, we actually use image hashing algorithms to calculate an image hash and then compare that instead. Let's move on to the demo. Okay, let me switch my screen to the browser so you can see our demo. Okay, so here's the demo. Can you see our website? Yes, I think you should be able to see it. Okay, so this is our web portal, as Matthias shown earlier. Where you can find the new feature is under this content integrity analytics. We have this images section. So you have this smart image hash button. You just have to click it. You can see currently smart image hash is off, right? So for this demo, I'm monitoring this web page. You can see here the URL. And this is the web page. So what I want to show here, is that you can see when we load the images, these images are all 300 kilobytes. So these are before we compress. You'll try to compress it later. But now I'll verify the image. I'll verify the web page rather. So this will force our system to check the web page now. I think Matthias mentioned normally this is done automatically on the schedule, but for this purposes of the demo, we'll force the system to check, right, so that we can see the results immediately. So you can see the web page is still okay. Yes, because this is how the state of the web page was when we entered it. So let's turn on the compression, right? So I move on to this tab. This is the Cloudflare example that I showed you earlier. So this is one of the companies where they do CDN with compression features. Currently it's off. I can turn it on. And then they say you have to purge cache to take effect immediately. So let's go and purge the cache here. Purge cache. Yeah. Purge everything. Purge everything. Okay. And now let's look at the page again. I'll refresh this. Okay, it takes a while, even though you say you have purged, right? It does take a while for the change to be reflected. Okay, now you can see that the image sizes are now much smaller. Previously, it was 300 over kilobytes. Now it's just between 60 and 100 kilobytes, right? So it is like 1/3 the size. So of course, if the user is on a slow internet connection, this means that the web page can load 1/3 faster. Can load in 1/3 of the time, so it will be much faster. So now we come and verify our web page. Remember that Smart Image Hash, I still haven't turned it on. If we verify the web page, okay, still says okay, because sometimes as I showed earlier, right, the CDN does not automatically compress the image on the first time or even immediately. right? So it may take a few tries to get the compressed version. Oh, okay, you can see that now it's showing warning. So yeah, it has detected these images have changed. So our system goes from okay to warning, and then you'll go to critical second after we have verified a second time. Right? So let's verify a second time. And you can see this is when we will send out alerts, and then you can see that these are the images that have changed. Without the Smart Image Hash enabled, the system would have detected that the images have changed when, and then the user or the customer will be looking at it, and then the images look the same. Why do you tell me that it's changed? So we'll turn on the Smart Image Hash now. And you can see the Smart Image Hash here, we have this slider. So as I showed just now, image hash is not exactly the same. The images look the same, but there may be slight differences. So this here is where you can adjust the threshold of how sensitive you want the Smart Image Hash to be, right? So of course, the more to the right you drag this slider, that means the threshold that you allow, the amount of difference that you allow will be bigger. So normally we suggest we just leave it as the default. It should work well enough for most situations, unless you have some reason to change it, then you go and change it. Right, so let me click OK, and then let's save. Okay, so remember to save the change. So after you save the change, you can verify the page again. You can see now the status is back to OK. So if the status is back to OK, it means that the verification engine didn't detect any change. So this is the result of Smart Image Hash. Even though the image file has changed, it comes in and compare the image hash and realize that the images actually have not been changed. It's still the same image visually. Right, so that ends the demo. That ends the Smart Image Hash demo that I have. Let's go back to the slides. So let me share the slide back again. Share. Okay, yes, you can see the slides. Yep. So if I move on, let's share some limitations of this Smart Image Hash feature. So one thing to note is that reduced false positives means there's a possible increase in false negatives. So the fact that we don't, the Smart Image Hash doesn't look at the actual image file, but rather looks at how it appears to be to the human, means that actually minor changes, you may not receive an alert. So this is like the way human, if I change add 1 pixel, actually you cannot notice it. So similarly, our Smart Image Hash will not alert. So this is something to take note of. Another thing to take note of is that there are actually non-visible parts of image files. For example, like image may have a comment thing to store, or like if you take photos with your camera or your phone, they actually store the dates that the photo was taken. These parts are not monitored by the Smart Image Hash feature because we look at how the image appears to the visually only, right? So if you're concerned about this, this is something to take note of. Another thing to take note of is that there are certain images that we actually monitor, certain formats like JPEG, PNG, and WebP. There's also an image size limit, dimensions-wise, right? So currently, this is a maximum of 4096 pixels per site. If your image does not meet this criteria, then they will still monitor it, but using the integrity hashing technique that we have already been using all along. So if you're concerned about the above limitations, you can still use the workarounds that I mentioned earlier, and they will still work, and they will be able to detect all these changes that Smart Image Hash may miss out. Right? So something to take note of. And also, Smart Image Hash is already available. If you have logged into the portal, you can find the option already there. And it's included with all WebRun SaaS subscriptions. So if you're already an existing WebRun SaaS subscriber and you're already using our service, you can enable it if you need it. So please try it and give us your feedback.